The test is on next Tuesday. So next class will be our review class. And it's not going to be the passive review that we did in pre-calc where I'm like, hey, you figure out what you need to study. We're actively reviewing next class. So we are going to pull up our Canvas. I'm going to have previously talked with Miss Napier about, because there's like a whole list. In reality, doing all of them is probably not going to happen. Like unless you're just living and breathing AP Calculus between now and next Tuesday, which is possible, but we're high school students. We got a lot going on. So what I want to do is go through that list and say, at a bare minimum, you should do these items. If you have time to do more, kind of have like a progression. Like these are the ones you should do after that. You know what I mean? Give you some places to go. There are released AP questions on there. From previous years. There are multiple choice. There's like things to practice so that we are prepared and ready to go. And just so you know, I think I talked with y'all about the test before that there's usually 4 parts to it. There's non-calculator multiple choice, there's calculator multiple choice, non-calculator free response, and calculator free response. This time we do not have a calculator free response just because we have not done that much with our calculators yet. Next unit, derivatives, we're going to go heavy into calculator use and how you use those. We'll have a free response for calculator there. Also, so that you know, we are going to, those sections are like specifically timed based off of like the AP timing so that you're practicing this in advance. Like the breakdown, obviously we're not going to sit down and take a 3-hour AP test here. You know what I mean? But like we've broken down in a 3-hour test, you have this long for multiple choice and you will have this many multiple choice questions. Therefore, these are the number of minutes you get per question. And that's the timing we're going to use on these too. So I will give you all a timer. We will all do first section of multiple choice. And I think with non-calculator, you get 2 minutes per multiple choice. For calculator, you get 3 minutes per multiple choice. Every free response is, it's either 10 or 15 minutes. One of the two. But we will all do each section together, and we will not turn sections in early because they're just, you will look over something. If you think you're done, you find something to check before the timer runs out. And if the timer runs out and we're not done, we pass it on and we move on. That's how it goes. It's going to feel different. I'm not saying, I said different. I said different. You are going to know all of the material that you need to know.
The first AP test is always the hardest.
But.
So it's not going to be like that last test we took in pre-calc, like the very last one where like we had
oh gosh, no, because that was completely blind, but it was also like open notes and stuff. This is not open notes, so it's got to be down a level from that. You know what I mean? This will have some things in there that you have to think like we did this in class and we did this in class and put it together in a way that maybe I didn't exactly present because that's AP thinking. But some of it we learned through doing that, and you might not pick it up if I just gave that all to you. Okay, and that's just, we're going to be all okay on that. But like I said, some of the direction on what to review and how to review will help you with that as well. So there's some things, while next class is not a like new material class, there will be things that you pick up during the review next class that will help you on the test because we're going through like how would you answer a question like that? How do you make sure you get your points for your free response stuff? And some of that comes with experience and some of it comes with me showing you some of it here. It just will depend. Remember that your raw score always feels worse than your actual score does if you're familiar with your AP stuff. In calculus, I got to check with her on the levels, but I'm pretty sure like a 50% gets you a 5. Okay, so like just know that. The raw scores feel a lot different.
How much do you think this first test will be per? Or do you do like the thing that like Steve
like the gradual?
It's like she has all the grading set up. And so like just so you know, like that will take me a minute longer on your grading then. Because she and I share 5th period off on B days. And so what I will do next time, I'll grade your multiple choice because I can do that. The free response is what I want to sit down because she knows exactly where you get point values for different statements that you make. And I very much want to help you with that as we go. And so like every test, we're going to sit down in 5th period and I'm going to grade your free responses. You'll have your test back by the next period. It might just not be my normal like same day of. You know what I mean? I will have stuff for you by the end of 5th period. And so because of that, she has like her... I've never had to grade AP style yet. So she has the like numerical curve that she puts on things. And it's not like a everyone gets 10 points thing. You know what I mean? Like it's different. Based off of, so the raw score, we will put in there, like if that was an AP test, what number you'd be at, 1, 2, 3, 4, 5. And then based off of that and those categories is your curve. Okay? And the higher you are in the class, the two classes as a whole, the higher your grade's going to be.
Oh, so the better you are, the better it is for you.
Yes.
Compared to
the other people, unfortunately, yes. And so
Also,
really
the
for
stuff
y'all,
where somebody like bombs the test.
do not share your information. You know what I mean?
Wait.
Wait, I don't get it.
Okay.
So,
All right, so let's chat intermediate value theorem. Okay, this one is just one of those, it's kind of a duh theorem. Like it makes sense to us and is very, very useful down the road for higher level thinking questions. We're going to call it intermediate value theorem, abbreviated IVT. Okay, you'll get used to it. It comes up a lot. This is not something that's going to be like here and then have to review it in like April for the AP test. Like it will come back many, many units. So just know that. So here's kind of the understanding of what the intermediate value theorem says. At age 10, you are 5 feet tall. At age 18, you are now 5 foot 11 inches tall. At some point between 10 and 18, was there a point that you were 5 feet 4 inches?
Yes.
Yeah, why?
I mean, to get from 5 feet to 5'11", you have to pass through the 5 square.
Exactly. That's what the intermediate value theorem says. To get from a lower number to a higher number over a continuous period of time, you have to go through every value in between that, right? Okay? So logically speaking, we would say yes. Okay? Yes, you would grow continuously. And at some point, be 5 feet 4 inches, right? This like logically makes sense to us. Well, what it does in math for us is if you have a function, let's say we have a function and we just know it's continuous and we know 2 points on it, okay, point 1 and point 2. If our function is a continuous function, okay, on this interval, whatever interval we're looking at, then there will be at least one place that it hits a certain value between your two y values, right? So that notation is that f of c is equal to y. And if you want to write this down a little bit more English, like real words, yes, that makes sense. You can put this down underneath it. So in other words, you cannot go from x equals a to x equals b without passing through all y values. Between f of a and f of b. Okay, so this will logically make sense to us as we draw it out. We are not going to draw these out every single time, but today, because this is new to us, we will. Okay?
So what is C?
So C is whatever that y value we're looking for in between those 2 points.
Okay.
So C is whatever y value that is in between. So we're going to take a look. This is one of those things that like, okay, so real life makes sense. And then we word it in the math words, and you're like, wait, maybe not. And so then we do a real example, and it will make sense to you. Okay? So logically speaking, let's look at example 3. Okay, we're going to sketch this for ourselves. Here is our example when I move down. There we go. All right. We are given a continuous function on the interval -1 to 5. We are also given 3 points on that interval. Okay, so let's sketch what we have. We have f of -1 is equal to 3. All right, so I'm going to draw my little graph here. I've got f of negative 1 is equal to 3. I've got a dot right here. I've got f of 5 is equal to 10. Oops, I should have drawn my x-axis a little bit lower there. Hang on. Adjust. Yep, let's all adjust. I don't have a whole lot underneath that. I know, I'm sorry. I should have looked at those numbers in advance. Let me try that again. 3, 4, 5, 6, 7, 8, 9, 10. There's 10. And 1, 2, 3, 4, 5. This is when we wish we were doing this on the iPad, right? Negative 1 is equal to 3. 5 is equal to 10. And in the middle, 1, f of 1 is equal to negative 2. All right, so we have those points. Yes? Any guesses as to how we could maybe play connect the dots or what this could look like? It could look like a parabola, right? It's just a continuous line, right? So going from the left one to the right one, I at least have to be able to connect these. And going from the middle one over to the far right, I at least have to be able to connect up to there. Okay? So it has to at least do that, yes? And I say at least because of this fact. Is there anything in this information given to me that tells me it doesn't do, like, I don't know, this? Do I know?
No.
I have no idea. It could do that. But at a bare minimum, it makes a U. Yes? It could do some other wiggles in there.
So no need to.
But no need to overcomplicate it. So you're going to see the words when we write this out, at least, because of the fact that it could go back and forth. Okay, now, I would like to show or answer the question, how many solutions are there to the equation f of x equals 1 on that interval? What is f of x equals 1? It's y equals 1, right? So here is my y equals 1. Now, let's talk about why the intermediate value theorem helps me. Because you told me in our height example, when I go from 5 foot to 5'11", I have to pass through 5'4", right? Logically speaking. So if we were just talking about this graph, logically speaking, going from here to here, is there any way I can avoid going through 1? No, at least once, right? Because think of my wiggle example. It could go down and up and then back down. I could go through that 3 times on the way. Same thing over here if I wanted to. Same idea, going from here to here, using our intermediate value theorem, there is no way I can avoid going through 1, correct?
Correct.
All right, now, the big thing with this that we get into is how to word your answers, okay? And so lucky enough for you, I have a nice little handout that has a script on it, okay? Do you have to memorize this? No. However, is it helpful for you as you start to write this? Absolutely. Because you need to include, if this was a free response question, a certain number of pieces of information. Does that make sense? Like if you want all your points, you've got to say at least these things. And so to start out with, we're going to use our little script here to write our answer. Okay, I'm actually going to look at the script in the bottom half first, and then I will address the top half. Because again, I want it to be less about memorization and more about understanding. So eventually, I'd love to get away from just like, this is always what you're going to write. However, you all need a starting point. Yes? Okay. We're going to go with that. All right. So do we all see that script in kind of the middle there?
Yes. Are we done with this page?
Nope. We're going to use that script to write our answer for this one.
Okay.
So first thing that you need to say is that our function is continuous on the interval. That is given to me right there. So I'm going to start with the statement, the function f of x is continuous on the interval. Now, what interval are we talking about in this problem? Interval. Okay, negative 1 to 5. For the intermediate value theorem to be true, it must be continuous on that interval. So we start off by saying that. That's like our prerequisite. That must be true, otherwise this does not apply. We then move on and say, therefore, there must be at at least. Keyword right there. Why do I say at least as a keyword? Because of the squiggly thing, right? It at least hits one time, maybe more. At least one x value, such that, what are we trying to prove? F of x is equal to 1. Okay, we are trying to show that my function hits 1 sometime in that interval. And here's our reason why. Because, okay, now we have 2 places to prove this, right? So we're going to have to essentially, now I've probably written myself out of room here, but we're essentially going to have to make this statement twice. I got to show it between first point and second point, and I got to show it between second point and third point. Yes? Does that make sense? Okay, I'm going to do between f of 1 and f of 5 to begin with. Okay, so the second point and the third point. We all okay with that? Okay, because f of 1 is equal to negative 2, and f of 5 is equal to 10, and then one last thing, and one of those y values is less than 1, one of them is greater than 1, yes? So because 1 is less than, 1 is greater than, it must go through in between. Yes, that's what we're saying. So our final statement will be, which one is the lower one? F of 1 or f of 5? F of 1, and not because of the 1, but because of the negative 2 y value. Yes? F of 1 is less than, what y value are we trying to prove that it goes through? 1. And 1 is less than, what's our second one? F of 5. Okay? So what you've said in that last statement is the y value for the 1 point and the y value for the other point are on either side of 1. 1 is between those. Therefore, it must go through 1.
Oh, so we're not talking about like the x value of 1 is in between those points. We're literally just concerned.
We're saying the y value. That's why we're using your f of notation.
Okay, I understand.
Yep. Yeah.
What made you not start with the f of negative 9?
This is what made me not start with it. We will repeat this exact same statement for the most part. Okay? So this same statement will be the function f of x is continuous on the interval negative 1 to 5. Therefore, there must be at least one x value such that f of x equals 1 because. So like this part right here is the part that's going to change for this. And here's the only reason I started with the second 2 points. F of negative 1. So I'm going to start over here and just say because.
But you want us to read.
Yeah, the whole thing. I ran it eventually. But right now, let's just talk about why. What is f of negative 1? 3. And then we're going between f of negative 1 and which one? I'm going f of 1. Because that's the middle one, yeah? F of 1 is equal to negative 2. Now, here's why I went between the second 2 first. Those came in a nice order. The first one was the lower one, and the second one was the higher one. Okay? This one does not come in a nice order for me. The first one's the higher one. The second one's the lower one. So you have to be careful how you write that last statement. Okay? So I would have to say, you can either flip the signs. Okay? So you can either say f of negative 1 is greater than 1, which is greater than f of 1. So I could write it that way and flip my signs. Because that's saying my y value for negative 1 is larger than 1, which is larger than my y value for positive 1. Or you can flip where you put your f ofs. Okay, so I could also say f of 1 is less than 1, which is less than f of negative 1. And that feels backwards because 1 is on the right and negative 1's on the left, right? But you're talking about the y values. So you got to put them in the correct order. Yes, ma'am?
Why can't you ever do f of negative 1 and f of 5? You always have to have that middle one.
It just depends on the question. In this particular question, we wanted to know how many. Therefore, I have to show that I have 2 solutions. And if I went from Well, let's just say I went from this one to this one. Does that pass through 1 at all? Like if I connected those two? No. So if I skip that middle value, I have no way of proving that it went down low enough to get to 1. Yeah?
Why didn't you say it had at least 2? Because it could just go through at once.
Usually we write one statement about one interval, so points 2 to 3.
Okay.
And then we write a second one about points 1 to 2. You can't do both at once because you have to break it into chunks and say between these two endpoints, I have at least 1. Between these two endpoints, I have at least 1. You don't have an argument for between the first and the last, I have 2 without including the middle. So, but you have to break it into 2 sections. Yes, ma'am.
So you said the f of negative 1 is greater than because it goes up 3, so it's higher?
Yes.
That's what we're focused on?
Yep.
We're
So
focused on the y value.
either of those 2 lines is appropriate, but you could not say f of negative 1 is less than 1, which is less than f of 1, because that's not a true statement, right?
It's greater.
It's greater than, right. So you've got to make that last statement mathematically true according to the y values. So you can either say the y value on the right is less than and the y value on the left is greater than, or you can say flip the inequality signs. Either way, it has to actually make sense for the numbers. It can't just be throw the left point on the left and the right point on the right and call it a day. That's not the same thing, okay? Now, this extra sheet here. Let's take a look at that real quick, and we'll finish up there. What time is this class out? Oh, hallelujah, I'm doing okay. All right. Well, I can maybe make up another example for you to do with this too, so we can practice our wording, okay? And we'll do it on the back of this so that we have it, okay? So let's take a look at our intermediate value theorem page, which I had, there it is. Look, I pull up everything in advance, so I know what I'm talking about. Now, things that you need to make sure of. If you are just given this, sometimes you're not given the points. Sometimes you're just given, here's your function, show that it hits this number at least this many times. So, how do you start? First, think about what y value you're trying to find or prove that it exists. It could be y equals 1, it could be y equals 0, it could be y equals 5, it doesn't matter, okay? You then may have to find yourself an ordered pair on either side of that value, such that one y value is lower and one is higher. So you're basically trying to find 2 points that are on either side of it. One is lower, one is higher, okay? So you might be asked to prove that there is a 0, y equals 0. So you need to find a point where the y value is negative and a point where the y value is positive and show that it is 0 sometime between them. Or you might be trying to say y is equal to 5. If you're trying to find y is 5, then you find one point where the y value is less than 5, one point where it's higher, and then show that it's in between, okay? So that being said, yes, let us just grab an example and do this. So if you want to flip to the back of this page, you might have to flip them back and forth from the statement there, but we will do that, okay? Now, does the script make a little bit more sense to us, okay? If you want to fill it in generically for yourself, you'll always be talking the interval a to b, whatever that interval happens to be, such that f of x is equal to that extra y value c, because f of a is some number, and f of b is another number, and c is in the middle of them. And again, they might not be in f of a and f of b order. It might be reversed from that, depending on whatever question you're looking at. Okay? All right. So let me make up an example for you on the back.
Oh, I have a quick question.
Yeah.
We didn't have to put, why did we put the less than or equal to, why didn't we put the 1?
Because it is strictly greater than. It has to be larger and smaller. It cannot be the same value.
And that's for everything.
I guess you can put it there. She put it there. I don't care. Doesn't matter either way, honestly. I give you what? What the...
Greater than or less than?
No.
So how
No.
do you know what it is?
Here, I'll show you. Let's try this one. I'll give you an example. Okay, let me just make one up here for you. Let's say we have the function, you can put this on the back for yourself. F of x is equal to, now let me see if I can make one that actually works. Negative x squared plus 4. Okay. Not always, no. I have to like mentally prepare myself and make sure I'm not saying something stupid. You know, we all live in fear of that, especially our first time teaching something. So if that's my function, show that f of x has at least 2 solutions. What are solutions? Zeros. All right, so although it says 2 solutions, mentally you're thinking to yourself, they want me to show that y equals what? 0. How many times? At least 2. All right, now this one, did it give us points? It indeed did not. Oh, look at that. It's a parent function we're supposed to know. What is this? It's a parabola that is upside down and moved which way? Up 4. So logically speaking, if I graphed this, does it indeed make sense that that would have 2 zeros? Yes. Sure would, but I got to show it. All right, so here's where we have to prove this. We want to prove that that goes across this line at least twice. So this is where that first example A kind of comes into play on this page. If you're trying to find y equals 0, you need to pick one point on either side of that line, one where your y value is negative, one where it's positive. All right, so let's just focus on one of these right now. Let's say I wanted to prove this side is equal to y equals 0. How could I find a point down here? Plug it in. What like x value do you think might give me a negative y value? Negative 4, negative 5. Do you know where that crosses? You can, but right now we're focused on that one, so we got to do like a negative x. On the other one, we'll do another one. Yep. Let's just think very smartly. I like my word smartly for this week. Do we know where that crosses the x-axis? Plus or minus 2, right? So if you're going to be nice to yourself, pick something just on one side of it. So maybe, how about negative 3? Can we do that? How do I find out what f of negative 3 is? Plug it in. All right, so take a minute. Plug it in. F of negative 3 is going to be equal to what number? Negative 5. We all okay with that? Now I need one on the positive side of that. Now, if I want one on the positive side of that, I got to get something like in here. What's the easiest one? 0. Yes? We're all okay with that?
Why have to get something inside?
Because we need a point that's going to be on this graph below that, and we need a point on this graph that's going to be above it to show that it hit 0 in between. Now, if I really want to make my life easy, I don't want to find a million points, so I'm going to find one kind of in the middle there, like right here, that's going to work for this one and the next one. So I don't have to plug in a million things, yes? So what is f of 0? 4. Okay? All right. So what I would like for you to do, take a minute looking at your script there and try to write a statement showing that this graph hits 0 at least one time between those 2 points. Yep. Our function is continuous everywhere because it's a quadratic and we know that. And we continue writing from there. All right, so are we good with our statement before I move on? I just start talking.
What is the f of 0 equals 4? Is that a part of the statement?
Yes, it is. Over here, this,
Yes.
that is not part of my statement. Nope, that was my label on my graph. Thank you. I just ran into that. If I would like to do this a second time, I must do it between now that and a point to the right. Yes? If I was being smart again, what point should I do? 3. Yes? Because I already know what that is because of symmetry. Yes? I know f of 3 is equal to negative 5. Now, the only difference for this one is going to be which one is first in that inequality sign, right?
But it would be the f of 0 is,
So you can either say f of 3 is less than 0, which is less than f of 0. 0, that's what I meant. Or you can reverse the inequality signs and say f of 0 is greater than 0, which is greater than f of 3. Okay? Would we like to repeat that process or no?
maybe.
Yeah? Okay, so everything would be good in my statement. Are we all okay if I just erase pieces? Is that okay? Okay, so I'm going to go ahead and say, now this one, the statement would be the same, except it would say on the interval 0 to 3, such that f of x equals 0 still, because, now that x equals 3 in here is not part of my statement either. That was just...
Like circus signs, so therefore there must be.
You've already stated that it's continuous, so I would not feel like I had to say that again.
Okay, so
I probably would continue it with saying, also, there must be at least one x value on the interval 0 to 3, such that f of x equals 0, because f of 0 is equal to 4, and f of 3 is equal to negative 5, and... Now, which way are we more comfortable? Are we comfortable making it always inequality signs go the same way? Or are we comfortable making it greater than, switching them? Okay, so if you're comfortable with greater than, I feel like, Sam, like you're good with that already. So I'm just going to keep the other way, if that's okay. Which of those y values is lower? F of 3. So I would say, and f of 3 is less than or equal to 0, which is less than or equal to f of 0. I'm going to put my y values in the right order. It has nothing to do with the x's. The fact that 0's on the left and 3's on the right has nothing to do with this. It is my y values, yes?
That's the same order as the